So, what is programming? The term programming means to create or develop software, which is also called a program. In basic terms, software contains the instructions that tell a computer or computerized device what to do. Software is all around you, even in devices that you might not think would need it. Of course, you expect to find and use software on a personal computer, but software also plays a role in running airplanes, cars, cell phones, and even toasters. On a personal computer, you use word processors to write documents, web browsers to explore the internet, and email programs to send and receive messages. These programs are all examples of software. Software developers create software with the help of powerful tools called programming languages. There are many programming languages, some of which are decades old. Each language was invented for a specific purpose, to build on the strengths of a previous language, for example, or to give the programmer a new and unique set of tools. Knowing that there are so many programming languages available, it would be natural for you to wonder which one is the best. But in truth, there is no best language. Each one has its own strengths and weaknesses. Experienced programmers know that one language might work well in some situations, whereas a different language may be more appropriate in other situations. For this reason, seasoned programmers try to master as many different programming languages as they can, giving them access to a vast arsenal of software development tools. If you learn to program using one language, you should find it easy to pick up other languages. The key is to learn how to solve problems using a programming approach. A computer includes both hardware and software. In general, hardware comprises the visible physical elements of a computer, and software provides the invisible instructions that control the hardware and make it perform specific tasks. Knowing computer hardware isn't that essential to learning a programming language, but it can help you better understand the effect that the program's instructions have on the computer and its components. A computer consists of the following major hardware components: a central processing unit aka CPU, memory as main memory, storage devices such as disks and CDs, input devices such as mouse and the keyboard, output devices such as the monitors and the printers, and communication devices such as modems and network interface cards. A computer's components are interconnected by a subsystem called a bus. You can think of a bus as a sort of system of roads running among the computer's components. Data and power travel along the bus from one part of the computer to another. In personal computers, the bus is built into computer's motherboard, which is a circuit case that connects all of the parts of a computer together. Now, let's talk about central processing unit in more detail. The central processing unit is the computer's brain. It retrieves instructions from memory and executes them. The CPU has usually two components: a control unit and arithmetic logic unit. The control unit controls and coordinates the actions of the other components. The arithmetic logic unit performs numeric operations and logical operations. Numeric operations include addition, subtraction, multiplication, and division, while logic operations include comparisons. Today's CPUs are built on small silicon semiconductors chips that contain millions of tiny electric switches, called transistors, for processing information. Every computer has an internal clock, which emits electronic pulses at a constant rate. These pulses are used to control and synchronize the pace of operations. A higher clock speed enables more instructions to be executed in a given period of time. The unit of measurement of clock speed is the hertz, with 1 hertz equaling 1 pulse per second. In the 1990s, computers measured clock speed in megahertz, but CPU has been improving continuously. The clock speed of a computer is now usually stated in gigahertz. Intel's newest processors run at about 5.6 gigahertz. CPUs were originally developed with one core only. The core is the part of a processor that performs the reading and executing of instructions. In order to increase CPU processing power, chip manufacturers are producing CPUs that contain multiple cores. A multiple core CPU is a single component with two or more independent cores. Today's consumer computers typically have 2, 3, 18 and more separate cores. Soon, CPUs with hundreds of cores will be affordable. Before we discuss memory, let's look at how information, data and programs are stored in a computer. A computer is really nothing more than a series of switches. Each switch exists in two states, on or off. Storing information in a computer is simply a matter of setting a sequence of switches on or off. If the switch is on, its value is 1. If the switch is off, its value is 0. These zeros and ones are interpreted as digits in binary number system and are called bits, binary digits. The minimum storage unit in a computer is byte. A byte is composed of 8 bits. A small number such as 3 can be stored as a single byte. To store a number that cannot fit into a single byte, the computer uses several bytes. Data of various kinds such as numbers and characters are encoded as a series of bytes. As a programmer, you don't need to worry about the encoding and decoding of data, which the computer system performs automatically based on the encoding system. An encoding scheme is a set of rules that govern how a computer translates characters, numbers, and symbols into data that computer can actually work with. Most schemes translate each character into a predetermined string of bits. In the particular ASCII chart encoding scheme, for example, the character C is represented as 01000011 in 1 byte. A computer's storage capacity is measured in bytes and multiples of byte as follows. A kilobyte is about 1000 bytes, a megabyte is about 1,000,000 bytes, a gigabyte is about 1 billion bytes, a terabyte is about 1 trillion bytes. A typical one-page Word document might take about 20 gigabytes. Therefore, 1 megabyte can store 50 pages of documents and 1 gigabyte can store 50,000 pages of documents. A typical 2-hour high-resolution movie might take about 8 gigabytes. So it would require 160 gigabytes to store 20 movies. Alright, now we can talk about memory. A computer's memory consists of an ordered sequence of bytes for storing programs, as well as data that the program is working with. You can think of computer as the computer's working area for executing a program. A program and its data must be moved into a computer's memory before they can be executed by the CPU. Every byte in the memory has a unique address, as shown in the following picture. The address is used to locate the byte for storing and retrieving the data. Since the bytes in the memory can be accessed in any order, the memory is also referred to as a random access memory, which is RAM. Today's personal computers usually have at least 4 GB of RAM, but they more commonly have 6, 8, 16, and 32 GB and more. Generally speaking, the more RAM of a computer has, the faster it can operate, but there are limits to this simple rule of thumb. A memory byte is never empty, but its initial content may be meaningless to your program. The current content of memory byte is lost whenever new information is placed in it, like the CPU. Memory is built on silicon semiconductor chips that have millions of transistors embedded on the surface. Compared to CPU chips, memory chips are less complicated, slower, and less expensive. Alright guys, this is pretty much it for today's video. In the next episode, we'll be talking about storage device and beyond. Please do not forget to subscribe, share the video with your friends, hit the bell button as it notifies you when I create new episodes. This has been Tech and Talk. Let's go!